I'd like to welcome everyone to the CSE Department Colloquia. Today I'm very pleased to introduce Kentaro Toyama, who will be giving the talk that Kentaro got his computer science degree from Yale University. He went to Microsoft Research, where he was a researcher in computer vision for quite a few years. He won the prestigious Mar Prize for his work on tracking algorithms. He took a year off at one point to teach calculus at Ashesi University in Ghana. In 2004, he co-founded the Microsoft Research India Lab in Bangalore, where he is now leading the Technology for Emerging Markets group, and he will be talking about that work today.
Great, thank you, Richard. Thanks to everybody for coming. So what I would like to do today is primarily for the computer science and engineering audience in the room, although the talk will be broadly applicable. What I want to do is make a case for the fact that there is compelling technical research to be done in the domain of global human development, especially if it's done within a multidisciplinary effort. And I'll mention that actually some of the pioneers in this area, like Tapan Parikh, are actually from University of Washington. But what I really want to do is get more involvement from the technical research areas in this particular area. And what I'm going to do, since these are very big themes, is to focus on a particular case study of a project that we've been doing in the lab in Bangalore over the last 3.5 years. And before I do that, let me give you a little bit of a brief background on India, as well as the context in which we're doing this work. So this is a series of photographs of the campus in Bangalore for a company called Infosys. Infosys is today not only one of India's most successful IT companies, but one of the world's most successful IT companies. They actually are now at the point where they're outsourcing work back to the United States. And what's interesting is that this is one of the countries that's leading the charge in India for national economic development. Meanwhile, in the same country, you find lots and lots of little internet cafes that spontaneously pop up in environments like this. You can see here, this is a busy city street in a town outside of Bombay. And you can see there are people who are still selling vegetables on the streets for ridiculously low prices. And nevertheless, this is an environment in which entrepreneurs feel like they can actually make money by running an internet cafe. And then meanwhile, the country is still primarily rural. At least 2/3 of the country lives in what the government classifies as rural areas. Many of the rural villages look like this, where there is no pavement on the roads. The housing is built of mud and brick, and of course there's thatched roofing. In this particular case, this is a unique village in that an agricultural company has installed this particular satellite dish to provide internet connectivity to this particular village. And what I really want to get across with all these photographs is that there's this interesting question that arises with respect of the place of computing technology for global development. And this is, I would say, there's very strong opinions on both sides the degree to which you can do this. So these are two quotes by two prominent technologists. Some of you may be able to guess who they are. The first one says, kids in the developing world need the newest technology, especially really rugged hardware and innovative software. And the second one says, the world's poorest 2 billion people desperately need healthcare, not laptops. So you can see this is the span of different opinions about the potential contribution of technology in development. And let me just show you who said each of these things. What's interesting is that both Nicholas Negroponte and Bill Gates have actually moved a little bit to the center since making these statements. And what my group in India does is to explore the full possibility in that range. So we have a group that does its best to try to understand the relationship between technology and society in the context of the developing world, and also to try to invent new technologies which might ultimately help development. The team is very multidisciplinary. We have people whose backgrounds are in anthropology, sociology, and economics, as well as people who do design. And then, of course, we also have computer scientists and other engineers. Over the years, we've had a variety of different kinds of research projects. On the social science side, we've looked at just how people use technology already in the developing world. Jonathan Donner, who is one of the people in this group, is actually one of the world's leading experts on how mobile phones get used in the developing world. We've looked at projects like rural PC telecenters, where People take PCs to rural villages and try to start businesses around them. And then we've also done a number of different projects around, for example, using video as a way to deliver education, either in a primary school context or in an agricultural context, as well as mobile phones for things like aiding microfinance or, again, operations for agriculture. And what I'm going to talk about today is a particular project called Multipoint. And one thing I'll mention is that quite a bit of this work has been done actually already in collaboration with the University of Washington, oftentimes through students who've come to our lab as interns. And that's been a very productive collaboration. So let me go back to our case study and give you in particular the kind of background to this particular work. We've done this work over the last 3.5 years. And it has been done with quite a few different people involved. Most of these are students who've been in the lab as interns. I want to particularly call out Joyojit Paul, who is here now in the information school, and Uday Singh Pawar, who was one of the researchers who led a lot of the technical prototyping of the project I'm going to talk about. All right, so the context is education, in India specifically, but also in developing countries overall. In India, there are about 300 million school-aged children in the country. And most of them, of course, come from very poor families. What's interesting is that despite the significant economic boom in the country, the country is still a third world country. And so the amount of money that the government spends on education per child per year is still on the order of $100 US, an incredibly small amount. And as a result of all of these economic difficulties, there's no end to the difficulties that these schools face. This is just one photograph of a primary school in Tamil Nadu. And you can see they're holding classes, first of all, not in an actual school building, but in a little gazebo structure. When I went there, these children were using the ground as a blackboard and literally just scratching letters and numbers into the ground with sticks. And if you visit all of these schools, you'll find that they're just problem after problem after problem. And coming from a technology background, it's not immediately obvious which of these problems can be solved by technology, or if any of them can be solved by technology. And that's where spending a lot of time understanding how schools work and how people are motivated in these school environments actually gives you a little bit of help in identifying problems that could conceivably be addressed by technology. So one such problem is student absenteeism. So this is a photograph I took in northern India. And what's interesting here is that immediately after visiting a school where I saw a whole bunch of kids in class, I went outside and there are a whole bunch of kids not in class. And so student absenteeism is a problem that happens throughout India. A lot of the causes are that parents want their children to be doing other things other than going to school, whether it's working to help support the family or babysitting younger kids and so on. One way that it turns out is very effective in combating student absenteeism is to provide free meals. So there's a program in India called midday meals, and this has turned out to be very effective as a way to get students to school. This is a very successful program, not just in India, but in other countries. This is a photograph from Ghana. And actually in the United States, there are programs like Head Start that provide free breakfast, for example, that serve the same purpose. What's not immediately obvious, that it turns out that PCs have the same capacity to draw students to schools. So one of the things that's very interesting in India is that the entire country, even in very remote rural villages, is extremely aware that there is something happening in the economy, and a lot of it has to do with the technology industry. And so parents feel that any kind of education on computers ultimately will help their children with future job prospects. And the children, of course, are always excited about computers. And then governments and administrators sensing what the parents are feeling, these are their constituents. And so they have a very strong desire to put PCs into schools. In fact, just this year, the government of India is about to spend on the order of several $billion trying to push more PCs into schools. And what's interesting about this is that the moment you put a PC in a school that is open to use for children, we have very strong anecdotal evidence that I'd eventually like to study at a larger scale, that the retention rate for students goes up. So students attend school more just because there's a PC that is being used by students. So if for no other reason than that symbolic value of the computer, there's some potential value to putting technology in schools. Now, of course, the real question is whether or not there is any practical value to learning about computers in schools for students in the way that their parents actually want. And it turns out that at least in certain kinds of environments, like Bangalore, where there's a very fast-growing economy, having some kind of understanding of PC usage is taken as a proxy by employers that you are different from the rest of the pack, of which there are many, many people. And so there's again a reasonable amount of evidence that we're collecting increasingly that if you have some kind of, if you can demonstrate a certain amount of PC ability, it often translates to the possibility of getting a very low-level white-collar job, which is often much better than any kind of blue-collar job that you can possibly get. Employees themselves often express additional confidence because they feel like being able to use a computer means they'll be familiar with the tools of an office environment. And then IT training centers, there's no end to the number of IT training centers, especially in India, which are advertising these kinds of services. So the demand is definitely there. Now, of course, what you really want to do with the computers in a school environment is to have them contribute in some way to the basic education that those schools are delivering. And so this is part of what Jojit was studying when he went to visit a bunch of schools. About 18 schools, all told, in the summer of 2005 when he did one of his early internships with us. And he came back with a series of photographs, which I'm going to show you. Basically, these are photographs of computer labs, so schools that already have computers in them, and the way that they're being used. And you can see here there are 6 students and 2 PCs. Okay? Here's another photo with 5 students and 1 PC. And it's not at all unusual to find 9 students to 1 PC. I've also visited quite a few schools over the years, and I'll say that at least in the lower income schools, I have never seen an environment in which there is 1 PC to 1 person ratio. And that's simply because of the restrictions in the financial resources that these schools have. So one of the things that Jojit observed was that anytime this situation happens, inevitably what you find is that a dominant child takes over the mouse and the keyboard and monopolizes all of the interaction. All of the other kids are basically left, just left to their own devices and trying to influence that child to do certain things. But ultimately, they are left out of any possibility of interaction. And if there's any interesting learning going on, they're not taking much part of it either. So the question is, what can you do to alleviate this problem? And what I want to do is first talk about 2 potential ways that this could be solved. Okay? First, let me talk about what Jojit himself proposed. And the idea that Jojit had was, let's just shuffle the seating, because it always seems that the student who ends up in the middle often controls the mouse and the keyboard. And this actually turns out to be a reasonably simple, it's a very easy solution to implement, and it works reasonably well in that children do seem to have a different dynamic every time they sit in a different spot. What's interesting was this was a suggestion that Jojit made immediately after spending a couple of months in these schools. And this was also a time when Jojit was just beginning his investigations in ICCD. And so there's nothing in here about any kind of technology-based solution to this particular problem. And I don't mean to say this as an indictment of Jojit, because since then he's been very active in a lot of technology-related problems as well. But I want to illustrate that this is the kind of the first pass solution that arises if you're thinking in terms of other solutions other than technology. Okay. On the other hand, a very technology-centric solution is the one laptop per child project, which probably most of you have heard about. So here the idea is to do whatever technology research is necessary to drop the cost of a PC to such a low point that conceivably every child on the planet could own one. I'm not going to say there's a lot of criticism that you can read about the old PC project online and so forth. And I'm not going to say too much about it, but I am going to make one point which I think is the key criticism of this particular approach. And that is basically that the cost of a technology, particularly in a poor, impoverished environment, is not primarily in the hardware or the software. And this is something that's actually true in the developed world, right? So for example, at Microsoft, which is arguably one of the largest technology companies in the world, we spend an incredible amount of money every year on maintaining a IT staff that has to take care of all of the technology that's in our labs. We haven't found a way yet as an industry to be able to operate technology without any kind of other support. And the same is particularly true in an environment if you were to provide laptops for children in schools. the cost of distribution, maintenance, replacement, training for the teachers so they can use the technology better and so forth. If you just make very conservative back-of-the-envelope calculations, you'll still find that on a per-year basis, even a $100 laptop would cost you probably at the very minimum $250 per child per year to maintain. And if you assume that a single laptop lasts 5 years, that's over $1,000. So all of a sudden, you don't have a $100 laptop project, you have a $1,000 laptop project. And for this very reason, basically what's happened is that this project has stripped away everything that most commercial sellers of technology insert in the cost of the technology, and then is effectively pretending that that cost doesn't exist. And I would say that's one of the reasons why this is something that many governments in developing countries actually balk at when they actually consider what they would have to do in addition to support all of the technology that would be required for one laptop per child. And then let me remind you once again that the Indian government spend on public education is, again, less than $100 per child per year. So we are talking about basically it's an impossibility to assume that these laptops are somehow going to make their ways into the hands of every child in the country. So let's go back to these photos again. When I saw these photos, my background is computer science, and so the first thing that occurred to me was, okay, there is a very easy technology solution to this particular issue, and it's simply to provide every child a mouse. So we jokingly call this a one mouse per child project. And for every mouse, there is a differently colored cursor on the screen. And effectively, what this does is it turns the PC into a kind of multi-person game environment, which as long as you write software for educational purposes, you can now effectively incorporate many, many more children per PC into interaction. Technically, basically, we went through several different iterations of how best to do this, and it turns out that the easiest thing is to kind of hijack the mouse event callbacks and then insert our own, where we draw our own cursors. And then the programming model is effectively almost exactly the same as the original one where you catch mice events and so forth. And so it doesn't change that much for the developer. There's one issue with this model, which is that it doesn't immediately make sense to existing applications. So for example, word processor doesn't really know what to do with all of these mice clicking all over. But you can write software, again, like this one. Here the idea is that the students hear a particular letter of the Hindi alphabet, and then they race to see who can click on the correct one first. So we started off by just prototyping and testing this idea very informally. And you can read some of the results that we saw, very obvious to see. But what I want to do is show you two photographs. This is like the before and after photos that you see on infomercials. So this is before multipoint. Okay, you see one mouse. And you can literally see how the kids crawl all over each other and climb all over each other to get any kind of interaction with the computer. And here is the after multipoint case. And hopefully people in the back can see as well. But you can see there's a visible change in the expression that the children have. These are these are not particularly, we didn't stage these photos in any way. And what's interesting is that if you actually watch these students over time, in the first instance, what happens is that most of the kids eventually get bored. And what's interesting is even the kid by himself gets bored because nobody else is paying any attention to him anymore. And within a few minutes, everybody's off the computer altogether. In the second case, they're playing the same boring game that you saw earlier, this one. But now, all of a sudden, they're really interested in the game because there's this social angle that comes in from gameplay. And I compare it to the same reason why computer games are more interesting when you're playing with other people than when you're playing just by yourself against a computer. Now, one thing I'll say is that this particular field is full of photos of smiling children sitting in front of computers. We obviously have to make a stronger case than just a photograph with respect to whether this has any educational value. So we conducted a more formal evaluation, basically comparing how much students could learn on a single PC by themselves versus an environment where there's multiple children on a single PC. We just wanted to make sure that at least they can learn approximately the same amount. And to do this, we had to think a little bit about the kind of task that we want to test. The ideal task would be one in which there was some kind of educational value and one which is measurable in the short term. Ideally, something where the general idea of the game could transfer across multiple subject areas so that it wasn't restricted to just one particular topic in physics or history or something like that. And also something where there's actual value in the investigation purely for the kids that we experimented with. So we decided that the task of increasing children's English language vocabulary by basically matching images against words would be one way to do this. And we set up a game where the single-person version of the game looks something like this. Basically, we flash an image of a particular animal, and then there are 4 multiple-choice options, all written in English, and the goal is for the child to click on the correct response. We want to test this kind of very simple game under 4 different conditions, and so I'll describe how we vary them. So one condition is the condition that we find natively in schools where there's multiple kids, just one mouse, and still one PC. And here the game is exactly the same as in the previous case. And then there's a situation where we have multiple mice. So here we have 2 different versions. One is a competitive version that we call multi-mouse racing. Another one is collaborative, and it's called multi-mouse voting, and I'll show you how those are a little bit different. In the racing version, basically the goal is to be the first to click. And if you click on the correct answer, the game proceeds to the next screen or the next word. And then in the collaborative version, all of the children have to click on the same answer before the game proceeds. Now, the important thing here is we want to be able to compare kind of apples to apples. So hopefully, if you think about it a little bit, you'll be convinced that both of the multi-mouse versions of the game reduce to the single-person version of the game when n equals 1, when there's only one student. Okay? So basically, all that we're doing is changing the number of people and not fundamentally anything about the nature of the game, what they're learning, the nature of the interaction. All right. We conducted a study in a couple of schools just outside of Bangalore with 6th and 7th graders, a little bit over 230 of them. And basically what we did was we put them into either single-person modes or multiple group modes. And each of the group modes was with 5 people each. We created some groups that were all boys, some groups that were all girls, and some that were mixed. And basically what we did was to run 7 minutes for a paper-based pretest where we checked the students' vocabulary before they had an interaction with a particular game. And then the 30 minutes when they were running the game, and the game was effectively allowing them a chance to learn more vocabulary. And then 7 minutes post-test, which was effectively the same paper-based quiz with a lot of the questions shuffled so that it's not the same set of questions, but basically checking the same degree of vocabulary. And ultimately, the one number that we really were interested in was change in vocabulary, how much the children learned as a result of playing the game. And then we also had effectively spyware logging all of the activity that was happening on these screens. Okay. I'll show you some of the quantitative results first. So the basic result that we found was that the multi-mouse voting version of the game, in which students had to vote on the same answer before going forward, showed statistically no difference in terms of the number of words learned by each student compared with a single-person, single-user scenario, single-mouse scenario. Okay, now this is the only mode which had that same characteristic. It turns out that multiple students with just even one mouse does reasonably well under certain instances and certain configurations, but not as consistently as the multiple mouse with voting. There were some interesting gender effects in particular, and you can see that over here in the graph between the boys and the girls. So with the boys, if you set them up in an environment that effectively doesn't force collaboration, they will do anything they can to win. And what that means in the context of this game is that they will just click madly without paying any attention to the words or the pictures. Very typical, probably. Interestingly, if you design the game such that it effectively slows them down and forces them to pay attention to what's happening on the screen, then they're able to learn just as much as if they're either left by themselves or working in a more collaborative environment. The girls, interestingly enough, actually did better on the whole anytime there were multiple girls sitting at a single computer. So they actually did consistently better when they were in a collaborative environment, which was very interesting to begin with. And they actually did just as well across all of the multi-person modes, whether or not they had multiple mice or not. So there's something very interesting happening there. I'll show you a little bit more about what's happening with the boys. So this blue line indicates the rate at which clicks are happening per unit time. And you can see that this is increasing when you start the boys on a game that is set up to be competitive. So basically, at first they realize, okay, what's the game? And once they figure out what the trick is, they just, they'll just click as fast as they can. Qualitatively, there's some other interesting observations. All of the multiple mice modes actually had a lot more kind of social engagement between the students. And it turns out that at least the competitive mode actually had more interaction between students. Everything from encouraging each other to yelling at each other. A lot of this kind of interaction was actually, was mostly positive, but there are cases where there are, threats and it kind of desires to get other students to do what other children want them to do. A lot of the dominance behavior disappears when you have multiple mice, but some of it still stays. So it doesn't fully solve this problem of having one dominant child kind of taking over the proceedings. But in many cases, it does weaken that possibility quite a bit. And then the other thing is that even though in a lot of the schools that we visited, the computer room is often used as a kind of babysitting room for the teachers, where they go off and either teach other classes or do other things while children are sitting in the computers. But in this particular case, we find that the teacher supervision is still very critical, even if you provide a more peaceful environment where every child has some ability to interact with the computers. We've done a number of different research projects branching off of this, and they've been published in various different outlets. And I think Kai has been particularly supportive of this particular kind of work in trying to understand how, how designs of computers can actually be adapted to developing world environments. One thing that's interesting about this project, which is not always true for all of our projects, is that Microsoft as a company recognized the value of this for its own business. And so relatively early in the process, a group that's called Unlimited Potential in Microsoft, which is a group that is effectively trying to design products for emerging markets around the world, decided to turn this into a formal software development kit. So right now you can go to the site and basically download an SDK that effectively has abstracted all of the multiple mice functionality, and then you can write code on top to write various different kinds of games. Since then, they've been putting in gradually more and more marketing efforts to try to get countries to adopt it, as well as educational content developers to write content for it, and it's being used in about 170 schools around the world. Thailand is a particularly interesting country for this. They've been very excited from the outset in terms of this possibility. And I've talked to a lot of people in ministries of education around the world about Multipoint, and every time they see this project, basically they come to me and say, when can we get this? And what they have in mind is they are operating with a particular IT budget for their schools, and they have a certain number of children that they're trying to reach. And the one thing that they know is that this budget is not enough to reach this many children, and multi-mouse is one way to actually achieve that. I'll mention that, interestingly enough, from a technical standpoint, it turns out that there's nothing new about the idea of using multiple mice with a computer, and even in an educational context. So going back as far as 1991, there's been a lot of work, particularly in the Kai community, around trying to understand how multiple mice might help with collaboration. But what's really interesting about all of this work is that no one thought of it as a way to help computing reach more children, because they were all operating in environments that had enough computers to go around. So instead, their focus is always on collaboration. None of these groups has ever done a study comparing the degree to which just brute force educational value can be gotten out of a multiple mouse scenario versus a single mouse, single PC scenario. Instead, they've worked to try to see how collaboration can be enhanced and so on. And one thing that you get when you read these papers is that there's a reasonable amount of, there's almost this palpable desire to find some interesting collaborative excuse to use multiple mice. Whereas we think we found the one critical reason why multiple mice might be interesting on PCs. Meanwhile, there's also a whole lot of work in terms of trying to understand how computers can best be used in education in the developing world. And the one thing I'll mention about all of this is that multipoint is a solution which, in retrospect, is extremely simple to understand. I mean, technically, there's not that much to it. And as a concept, it's very, very easy. And yet, despite a lot of energy being spent on trying to develop better technologies or improving existing technologies for developing world education, we are definitely the first to hit on this idea of having multiple mice per PC. And I think this speaks to some of the value of having this very multidisciplinary group. I would say it's a combination of understanding exactly what the problems are, the fact that, for example, computers actually, just the interaction with computers is something that parents see as valuable, as well as the fact that there are also technologists wondering, how can we solve the particular problem that there are too many students per PC. That is really the thing that brings this particular solution around. And I'll mention that multipoint is, it's a very simple solution, but it solves a very real need in the developing world. One thing that I think is good about this particular technology is that it's sustainable to the extent that PCs are sustainable in the same schools. So if you can sustain a PC, it's not a significant matter to add a few extra mice. The same people who are providing support and maintenance and so forth can deal with it. And any teachers who are familiar with PCs as a general concept will find it relatively easy to understand multiple mice. It's also nice in the sense that all of the stakeholders in education who are putting PCs in schools also see a benefit in having multiple mice per PC, simply because in many situations, sometimes when you try to create a particular kind of change in an environment, you often find that there are people who have a vested interest in the status quo and will fight certain kinds of technology changes. But in this particular case, all of the incentives are aligned. And then finally, for researchers, I'll mention that this starts off being a very simple technology intervention, but it actually opens a door to a whole variety of research. And that's what I want to talk about next. Since this particular project, our group has been involved in quite a few different additional kinds of research that are basically building on the paradigm. We're trying to investigate more things about what happens when you have multiple kids on a PC. This is one where, again, Joji was involved when he was still at UC Berkeley. And basically, what we were interested in here is to understand how you can mitigate dominance behavior by effectively balancing the benefits of competitive play, in which there's a lot of excitement and engagement, with the collaborative play, which tends to actually get students to learn and pay attention. And basically, the way to do this is potentially to create teams which are playing against each other. So there's a lot of benefit that you also see in kind of team sports as well. Another thing that's been very interesting is a number of people that we've been working with have considered the possibility of using multipoint in an entire classroom. So if you have a single PC in a class with a teacher at the head of the class, and you have 20 to 40 kids in the classroom, what can you do if you provide every child in the class a mouse? And we've run experiments both in Chile as well as in China along these lines. Nima Moraveji, who was a researcher in the China lab, Microsoft China lab, started this project in China. And then we've also been collaborating with a professor in Chile to see what you can actually do with multiple mice. And this is actually a very interesting paradigm. It's the quantity, just from the change in quantity, the interaction changes quite a bit. And so you have to rethink what kind of games are possible, what kind of instructional paradigms are possible. Salima Mershi, who is a PhD student in the CS department here, she visited us last year for a few months to do an internship with us. And she investigated the question of how can you easily do text input under a multiple mouse paradigm. So the same constraints that prevent you from buying extra PCs for students can also prevent you from buying extra keyboards, even though extra keyboards would be interesting enough in themselves. But if you just have a mouse, is there some way that you could enter text effectively? And we tried a number of different things and think we have a couple of workable solutions. There's a lot of questions around, going back to collaboration. How can you design collaborative activities where there's actually peaceful, productive collaboration as opposed to fighting? I have some videos that I'm not going to show today, but where, even under a multiple mouse situation, students will end up, fighting with each other over who gets to control all of the mice. In this particular case, we've been trying to see how you can design, in this case, a drawing application so that it encourages everybody to collaborate. This is one example where three children effectively collaborated on a single drawing that actually looks reasonably coherent. We also have cases where kids just draw lines and cut up the territory and decide to do their own independent thing. And then finally, if you spend enough time trying to work with computers in actual classrooms, you find that the teacher is the one key person you have to convince. They are either your biggest opponent or your greatest ally. And one thing that we found is that, at least in the kinds of schools that we've been working with, the teachers themselves, even if they have a little bit of familiarity with PCs, are often not particularly computer literate. And so we need to design tools that make it trivially easy for them to use a tool in their classroom. What we've been experimenting here is to basically create game templates which isolate all of the interactivity in a game format, but then make it very, very easy for a teacher to edit the content, possibly even by just editing text files. So these are just some of the different possible ideas that have just emerged just from that initial idea of multipoint. And what I want to do next is kind of make an appeal to the computer scientists in the room that this kind of research exists all over the place if you're willing to spend the time to look for the right problems. So just thinking from a perspective of multipoint, I think one thing that we do quite well as computer scientists is to kind of think about trends. So if you think about the original situation that I showed in those photographs where there are many children surrounding a single PC, that's one end of a possible spectrum of sharing. At the other end is the situation that some people consider ideal, where every child has their own computer. And multipoint is kind of in between, in that you have most of the computers shared, but every child has their own mouse. And then, of course, there are thin client solutions that already exist in the market, where you can effectively have a single motherboard shared by multiple terminals. So then the question is, are there other places in between this continuum of sharing where you could conceivably share more or less of the hardware? And we think there is. There's a project that we've started called Split Screen, where the idea is to share the monitor, but have every child have their own keyboard and mouse. In this case, we split the monitor down the middle and give every person their own screen real estate. And then in each window, they're effectively running a version of the desktop. We've been testing this in an IT training center in a slum in Bangalore. And it actually works quite well, especially because these are students who have never had a single PC user experience before, so they don't realize what they're missing when they're only getting half of the screen. Other possibilities in education, one series of projects that I'm very, very excited about is what I call Featherweight Computing. And here the idea is to combine very low-cost audio electronics with imagery on paper as a way to generate a multimedia experience. And the great thing about this is that we can dramatically drop the cost of the required hardware to literally 1 or 2 orders of magnitude less than anything resembling a PC, and still get an experience that is very, very, that has a lot of the components of multimedia. And then on the other side, I think there are a lot of opportunities for computer science tools to be applied to the study of development. So in particular, as a field, we do a lot of things around modeling, around stochastic models, and I think some of these could be very easily applied to understanding different states that people go through, whether it's educational states or economic states. And that would, provide tools for economists and other people interested in development for understanding kind of how micro-scale events contribute to a larger macro-scale environment. And some of this work is already beginning to happen in economics, but I think we could actually accelerate that process by contributing to it. These are just examples in education. This is a kind of sampling of some of the other projects that we have going in the lab. And these are all ones which involve computer science in one degree or another in various states of completion. You can see underneath, at the bottom of each of the projects, what field of computer science could conceivably contribute to that area. And I would say the one thing that I've recognized, having done this for about 5 years now, is that once you become familiar with the environment and the problem, there is no end to the potential for technology to somehow support economic development in these communities. And so it's really a question of becoming familiar enough with the environment and developing the right intuition so that you find real problems that are actually addressable by technology. I won't say that all of these things will become fruitful, but I suspect that some of them will actually help. So before I conclude, let me mention a few things about what I've learned about kind of a multidisciplinary effort. As I mentioned, the team is very multidisciplinary in nature. And what I find is that most of the work that we do roughly falls into 4 broad categories, which you could count as qualitative and quantitative social science, design, and then computer science or engineering. And what's interesting about all these is, of course, they have their own methodologies, and they all bring their own skill sets, but they're also very different in their temperament and their approach to problem solving. So for example, computer scientists, we live in a world where you have to find the next killer app, which is so compelling that consumers cannot possibly resist. And meanwhile, sociologists are saying, are just as likely to find that a technology is contributing to social ills as they are solving them. And I think that tension, between incredible optimism and skepticism is absolutely critical to doing the right kind of work. The problem with optimism, running away by itself is that we often end up hyping the potential for technologies. And in this space, it's one thing for a consumer to waste a few $100 on a technology they don't really need, but it's another thing for entire governments to spend hundreds of millions of dollars on technologies they don't need. And so there's a certain amount of responsibility on our part to make sure that we're engaging with people who by temperament are looking for reasons why it doesn't always make sense to roll out a particular technology. In the case of multipoint, I think you saw how some of these factors go in just not only in helping to critique a particular solution, but also in defining problems. Oftentimes I find that the social scientists that we work with see problems in a very different way from the technologists, and that often helps us identify additional problems as well. I've been doing this, again, as I mentioned, for about 4.5 years. So what I also have are a kind of list of things that I have come to ask of the technologists that we work with, as well as the social scientists. And so what I'm going to do is kind of go through a number of these things. So first, for the computer scientists and engineers in the audience, of course, we want everybody to be open to a multidisciplinary effort. One of the things that I think is very difficult for engineers to do is to stick with a simple solution when the simple solution works. All of us have been effectively, we've been raised in an environment in which we've been rewarded for our ingenuity and our cleverness and for doing something so intelligent that nobody else could possibly understand it. And one of the things I find is that most of these areas, when you go into them, there's low-hanging fruit in terms of problems, in terms of solutions that could be had and which would make a significant impact if somebody were just willing to try it out. Interestingly enough, as you saw with multipoint, if you do follow that simple solution, it opens the door to a whole variety of interesting technical challenges that if you sit with the problem long enough, become more apparent. And I think that's the ultimate reward for doing work in this area, especially for computer scientists. There's a lot, I think, that we need also in terms of flexibility with respect to matching problems with solutions. And here I would say there's two approaches that work to different degrees. One is the traditional hammer model, where you have a hammer which you'll never let go of, and you go out in the world searching for nails that you can pound down on. That works as long as you're willing to walk away from screws that are out there in the world and let the people with the screwdrivers come and solve those problems. The worst thing that can happen is if you have the hammer and then insist on trying to nail a screw into the wood block. The other approach is to be relatively agnostic about the technology and cling to a particular problem. And at least from my experience, I think that works a little bit better in this particular area. It's a little bit harder to make work in the sense of, that maybe your particular expertise and background doesn't fit a particular problem. But I think, again, in an interdisciplinary or collaborative environment, you can make these things work through collaboration. And finally, I'll mention that, again, technologists often have great expectations for the technology. And I think one of the things that is important to keep in mind is that it's important to be somewhat realistic about the potential for impact. Global development and poverty are problems that have been around for forever. And it's not that we're going to solve any significant problems in poverty just by developing a technical solution. And I think the greatest harm we can do is to ourselves. So sometimes it's incredibly demoralizing to think that you could have this huge impact, and then when you put something out there that it's only had a small impact. But I would say it's that small impact that's really necessary to layer up over and over and over again. And so to the extent that you can be realistic about potential impact, I think you're more likely to stay in the game. For the non-technology disciplines, again, a multidisciplinary approach and openness to it is great. One way that can manifest is to be forgiving of technologists when they do their own project evaluations. Social scientists have a very valid point that anybody who does an evaluation of a project in which they've invested their own blood, sweat, and tears is obviously going to be biased towards a positive result. And that's absolutely true. At the same time, if we don't do our own project evaluations, nobody else will. So, I would say this is something that we just, we have to accept as part of at least the initial phases of a project. Maybe when it's reached a certain level of maturity, we can expect objective evaluations. But at least initially, I think a slightly biased study done in good faith is still more valuable than nothing at all. As I mentioned, a lot of non-technology areas are also very good observers of what's actually happening with technology and are very good critics of the problems with technology. And I would say that's absolutely essential for us to do our work in a very positive way. But it also helps if that critique is done in a constructive way. So it's not an out and out a condemnation of the concept as a whole that technology might actually make a positive difference to the world. I think one area where social scientists in particular can contribute quite a bit to these efforts is actually to help design the kind of social systems that also need to be in place in tandem with the technology. So oftentimes there are lots of situations I found where a technology by itself doesn't do much, but with the right social institutions and infrastructure, it can actually do quite a bit. And I think that's where people who understand institutions and human beings are very critical. And then finally, one thing I ask from the social scientists who we work with is to be a little bit pragmatic with respect to the kinds of explanations that they provide with respect to why technology X works or in a particular environment or doesn't. One thing I find is that in the same way that some technologists get very carried away with their own expertise, social scientists will also prefer an explanation that is more suitable for their field than the explanation that necessarily explains the most in a particular situation. And I think in those situations also it helps if we know the primary causes for things rather than secondary causes, even if they're very sophisticated in their explanation. So to summarize, hopefully I have made a slightly stronger case for those of you who are already thinking about this field in terms of convincing you that there is very interesting technical research that can be done to solve global development problems, and that it's absolutely important to do this in a multidisciplinary framework. I started off by talking a little bit about multipoint and how these themes run through that particular project, and then showed you a bunch of examples where computer science can plug in various different ways. Thank you very much. Any questions? Yes?
Can you talk a little bit about how you see the role of cell phones in either education or other work in the developing world?
Yeah, so as many of you probably know, the world now has more cell phones in active operation than half of the population of the world. It is probably the single most fastest growing device in the history of consumer electronics. And so a lot of people have begun to do the calculus of, okay, these cell phones are already out there, even in very poor communities. Perhaps we can do certain kinds of development efforts on them. I think this is an area that's rich with potential. It has lots of potential for exploration. And I think that exploration is good. It's also a time when a lot of mobile phone companies are coming to realize that they can help seed their own markets by encouraging the exploration. So I've never seen so many contests on mobile phones for development as I have in the last half year. The one thing I would caution is that, on the one hand, I do think that exploration should happen and continue, but I also think this is yet another technology fetish at some level. It's another way to hype a single technology, which may or may not be suited to a particular problem. So I would say it's really case by case. So certain problems I think are very admit to a cell phone solution, and then there are other problems where the cell phone by itself, regardless of how much technology you throw on it, will be the solution. So it depends. It depends quite a bit. We have some projects where we've done work with cell phones, some successful, some not so successful, and we also are gradually developing a little bit more understanding about what seems to work on cell phones and what doesn't.
Yes.
You had some very nice gender results as a byproduct of your evaluation. What about the middle ground? Was the result exactly the average when half boys and half girls were doing the task together?
So the question is, how did the gender effects manifest when there were half boys and half girls in these groups? Yeah, there was definitely some kind. There was no easy way to characterize it, but there are definitely some something in between happens. Sometimes the girls kind of go off and do their own thing while the boys are acting up. Sometimes the girls manage to control the boys. Sometimes the boys manage to dominate and make everybody crazy. So lots of different kinds of things happen. To be completely honest with you, we haven't looked at the data at the level of what's the average case. But at least if you look at the overall numbers, it looks like there is something in between does happen.
Do you see in the future this multidisciplinary approach influencing the way in which Microsoft as a whole might approach technology business in the future?
Okay, so the question was whether I see the multidisciplinary approach influencing how Microsoft does this business in the future. Actually, I would say that to some extent, the company had already begun to go in that direction even prior to our group. Microsoft, it turns out, has actually been reasonably aggressive at hiring, for example, ethnographers to help with the initial design and understanding of the customer and so on and so forth. And those kinds of efforts are increasingly gaining ground within the company, so that it's no longer software engineers who are making all of the decisions. I'm not sure that we will ever get to a point in the company where a team of economists and psychologists and anthropologists are working right next to the to the technology folks. But I do think that there is an understanding at the company that there are things that technology-led development where technology-led development doesn't work as well as it could, and so they're trying to involve more people in the process of design. Yes. Sorry.
So, do you have a sense of how the transition would be for these kids as they grow up and they're in this multi-point paradigm, and if they grow up and they start to work with one-on-one, right, with a computer? What are some transitions that could actually you can employ to?
Okay, so the question is, what kind of transitions might children go through from starting with a multi-point paradigm to a single user, single PC paradigm? Is that right? Yeah, so that's a good question. I have to say, so far we haven't put in a lot of energy into this. One thing I will say is that multipoint seems to be reasonably well suited for kind of primary and early middle school age ranges, and for the kinds of activities that schools tend to do on PCs in those age ranges. But it's certainly not one where I think it would be very easy, for example, to learn programming or even word processing. I think split screen, for example, is a much better environment in which to do those kinds of activities. I think the question of what happens in terms of how children adapt, I think will be very interesting, but we haven't really looked at it too much at this point. Yes.
Could you talk a little bit about how the both computers in developing regions works into engineering education? Perhaps specifically regarding HCI, which is one of the strengths at the university here.
So let me see if I understand the question. So the question is, how can computers in developing countries help with engineering education?
Yeah, like within an engineering education curriculum, how well does it fit in?
Oh, within an engineering education curriculum, and you mean computers in general,
yes.
With or without multiple mice?
Oh, regardless of multiple mice, the computers in developing world, how does it fit into
engineering? That's a good question. I can't say that we have put a lot of thought into it directly. I think obviously if you're learning about computers and computer programming and anything that fundamentally is about engineering with a computer, you need a computer to actually be able to learn these things. All too often I've seen environments where there are an increasing number of students, for example, in India, who are graduating with computer science degrees as an undergraduate education, and literally they have not had a chance to do any significant programming on a computer. And I would say, they're not in any way equipped to have, to work in an environment that is expecting them to be able to program. On the other hand, for general engineering education, I think that question is as hard as, what is the most valuable way to use a computer in any kind of education itself? And I think that's something where, as an industry, I think we're still quite far from understanding that. If I were to advise somebody who was about to go through an engineering program and they had to choose between a program that sat them in front of a computer with whatever best software exists for engineering today versus a program in which there was a very good teacher, I would still send them to the teacher.
Let's take just a couple more questions.
Any more questions?
So I can imagine a situation in the poorest schools where spending the money on books or perhaps improving teachers might be better. So is there quantitative research that says where the boundary is, where you can start adding technology so that actually improves education?
That is a fantastic question, and I would say at this point we don't know. That is exactly the kind of work that we are hoping to do ourselves with our, especially with our economists, and we're beginning to kind of get into that question, but it's relatively difficult. We are pursuing this project because at some point we saw that regardless of whether it's a good idea or not, computers are making their way into schools. And so the question for us is, given that that's happening, what's the best use of those computers? All too often these computers end up either being door stops, gathering dust, or they end up in the administrator's office where the headmaster has access to the computer, but none of the students do. But that's a great question. Yeah, one more. There's somebody over here.
There was the hand up.
Okay, I just wanted to ask, given that whether there's a computer in the classroom or not, oversight of some kind seems to be necessary. Have you started thinking through ways to convince teachers or just have people of various kinds in the classroom?
So the question is, given that oversight of even computer labs is necessary, have we thought about ways to keep teachers in the classroom? We haven't actually tried to consider solutions for how to keep, how to encourage teachers to stay in the classroom. Again, I think that's more of an institutional, issue. But we have started working with a setting in which, different from multipoint, where there's a single computer in the classroom, and questions around how we can best support a teacher using that computer, either with a projector or with a monitor facing the children. So I think there's still a lot of interesting possibilities in that space too.
Thank you very much.
Okay, thank you.